Okay, so today is going to be talking about areas of something called a sector. Over here on the left, I've kind of drawn out a sector. Think of it like a slice of pizza or a slice of pie. You slice from the center, kind of like forming a central angle, and then that region that you form there, this is going to be something called a sector. So, sector of a circle. Now, to figure out our formula, we're going to start with the formula we do know. So let's say that we have a full circle. We know, or we should know, that the area is pi r squared. So let's work with that. Let's say instead of the whole circle in red here, let's say we wanted to find the area of just that semicircle. Well, to do that, we would just do half of that. So that red area is going to be pi r squared divided by 2. Okay, well, let's take that even further. What if instead of a semicircle, we're supposed to look at maybe this quarter of a circle here in green? Well, that would be pi r squared divided by 4. And then if we could take it even further, say we wanted to slice that in half, I'm going to shade it in as much as I can. Here, that's a 45-degree angle. That would be an eighth of a circle. So that area would be pi r squared divided by 8. Okay, so this should look kind of familiar. If you remember when we did arc length, we started with the length of a circle and then divided it out a couple of times to see what's the formula for any arc length, knowing the central angle. So it's basically going to work the same way. Area of a sector. So this depends on the same two things. It depends on the radius and it depends on your central angle. So it's going to look just like your arc length formula. Angle divided by 360, except instead of multiplying by a length, we're multiplying by an area. So this is going to tell us what portion of our area we're going to be finding. So what we're going to do is we're going to be given a couple of different size circles. They'll give us a different radius. They'll give us a different angle, and then based on those things, we have to figure out what's the area of that sector we're looking at. So I've got 3 quick examples here. So here they're saying find the area of the shaded region. They want us to round to the nearest tenth. So we need those two things. We need central angle and we need radius. Well, that's our radius. There's our central angle. I know it's kind of hard to see. This is supposed to be the shaded area there. And so go ahead and write out that formula like I told you all. Please do that for every question, because if you write it out every single time, by the time we take our test, you're not going to have to memorize them all. You'll already know them all. So angle over 360 times pi r squared. It's going to be 46 divided 360 times the radius is 5, then that's going to be 25 pi. And once you write this out, okay, so now it's calculator time. Go ahead and plug that in. Find mine here. I don't know if it's going to show up all that nice for you all. Let's see. Okay, so that's supposed to be about 10.03 blah 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 blah. They wanted to the nearest tenth, so we would say just 10.0. And we should say inches squared on there. Okay, so this one is supposed to be shaded kind of like the opposite way. So we're looking at this larger sector there. Now, they didn't give us that angle of rotation, but they told us everything else. So if that's 55, well, we've got 360 in a full circle, so take that away. Our angle, so angle over 360 times pi r squared. Our central angle then is going to be 305, because if that's 55, we have 305 left over to travel around. So that'll be 305 over 360. Our radius is 11.2. Got to square that thing times pi. Notice again, you can change that order of multiplication any which way you want to. So I'm going to type that in and see what we get. All right, so about 333.9. And make sure you put units squared on there. And then the last one here, we've got a radius of 10. They told us this rotation was 310. So if it's the shaded part we're looking for, well, that's going to be 50 degrees. Same old, same old. So 50 over 360 times 100 pi. Which is about 43.6. Okay, so I'm going to stop here and then post some other examples for you guys here in a minute.